Black holes are deceptively simple and yet incredibly complex. A black hole is a region of space where the pull of gravity is so intense that nothing can escape it, not even light. We don't have the physics to describe what a black hole is, because it leads to a paradox, a breakdown in our understanding of how the universe works. We only have 4 fundamental forces to describe how the universe works. Gravity of those 4 is probably the one that we have the most intuition for. You throw something up, it comes back down. But it's actually the least explored. Einstein really recognized that gravitational fields are equivalent to talking about space and time not being separate entities.
Einstein noticed that in certain situations, Newtonian laws of physics don't seem to hold. And that's why Einstein developed his theory of general relativity. We know that general relativity may not be a complete description of physics, and so in order to figure out where it's incomplete, you want to test it in regions that people haven't tested before. So people have tested general relativity on Earth, in the solar system, but never around a black hole that's 4 million times the mass of the sun.
The first question I was interested in was, is there a supermassive black hole at the center of our galaxy? If you had asked me, would I still be doing this project 20-odd years later when we first started, I would have just laughed at you. I grew up hearing the word no all the time. You're a girl, you can't do it. You're a girl, there's no way you can get into MIT. There's no way you can get into Caltech. I think I developed a passion for proving people wrong. We have been able to increase the evidence for supermassive black holes by a factor of 10 million. And we have done this by watching how stars move. My favorite star, its name is SO2, and it makes its journey every 16 years. We're at this point where it's closest to the black hole and is experiencing the strongest pull of gravity. So we have this first opportunity to get a direct measurement of how Einstein's theory of general relativity works near a supermassive black hole.
What we've found this summer is that general relativity does actually describe the motion of the stars around the supermassive black hole.
That's a transformational change in our understanding about not only the existence of supermassive black holes, but the physics and astrophysics associated with black holes.
Andrea, to me, is a brilliant scientist. Her dedication and her persistence really has been at the heart of this project in order to have the patience and the level of detail required to do this work.
When I was young, I wanted to be the first woman on the moon, but I think at the same time I also wanted to be a ballerina. I just became much more infatuated with the ideas rather than the physicality of moving myself. It's very poetic that we actually see the stars in motion doing this dance around the black hole. So what we want to do is we want to improve our ability to see a star like our sun, the center of the galaxy, because I think that's when we'll have the full view of how this dance really works.